Welcome, everyone. As Vic said, I'm Martin. Welcome to Leetspeak. And please don't kill me. So that's the topic of my talk. I might be getting old. I've been starting to think differently about stuff. I feel like the world around me is changing, and it's changing at a rapid pace. So I don't know if I attribute that to old age or if that's actually happening. And as I see that going, I see how we as software developers have this great power over the world. Victoria was talking about breathing life into things, and I don't really think that we understand quite how powerful that is. So I made this presentation because I understand how powerful that is. So I thought if I made a presentation about, please don't kill me, I'll have at least 400 or 500 developers on my side when it's needed. So all jokes aside, over the last years, we've made more progress than any other time in history. It's ridiculous. I mean, for the first, around the year 1000, we were just kind of cruising along, taking it easy. Not a lot of things changed, and fighting each other with sticks and swords. And then all of a sudden, boom, the Industrial Revolution. Coal. We figured out that there's a bunch of power stored up in this little thing, and if we release it, we have all sorts of inventions like, steam engines and trains. And not only that, other inventions came with it, like the typewriter and the telegraph. It was amazing. And then that was further built up when we discovered oil. There's even more energy, we can do more stuff. And then it kind of, we were just getting comfortable. Okay, this is going to be life now. And then in 1950, boom, computers. And a whole new revolution started. So this is Oppenheimer and von Neumann in front of a machine called EDVAC. So this is not the ENIAC, but it's another machine. It was built and mostly used for doing bomb calculations, right? And this is the birth of modern computing. So over the last 70 years, we've went from computers that fill rooms to these devices, right? So carrying it around in our pockets. And we're putting more and more responsibility and trust into them. We use them for communications, we use them for banking, we use them for our external memory, basically for everything. And I mean, the hardware in itself, this is cool. But it's the software inside of this that makes it powerful. It's all the apps. And we all interact with more and more software every day than ever before. And I'm just taking this from personal experience. I have no statistics to prove that. But I'm sure nobody here is going to try to contradict me on that point. And it's changed us, both as a people and as a society. Things are different now than they were before. And make no mistakes, there's no going back. This is life now. We can't go back. So, just to have an example, we've had oil for what, 150-ish years, right? And we started depending on it for everything. It's not only our fuel, it's how we get our food. It's used in creating medical supplies from plastic that we use in hospitals. It's used for cleaning products that we use to keep our personal hygiene up, but also clean the spaces so we don't get diseases. It's basically everywhere. And I don't think people understand how important it is. It's so important that we kill our planet to get more of it, right? And during in the year 2000, there was big oil protests in the UK when the price of oil was going up. So it only took 1 week of blocking refineries to basically bring the whole country to a standstill. That's how important it is. And I'm doing a claim here. I'm doing the claim that software is the new oil. So what do I mean by that? Well, imagine, what if all your software stopped working today? Where would we be? All right, that's extreme. What if one of the major cloud providers just goes poof? That's a crisis in itself. So we put much trust into the software. We put much trust into the software working. So much that we've removed all the analog fallbacks. That's how much we trust our software. What do I mean by that? Example, Starbucks in the US. Basic idea, we make coffee, we sell it to people, they drink the coffee. Their point of sale systems went down for a few hours. Can't sell coffee anymore. What? How is that possible? You can't sell coffee. Software is not there, we can't sell the coffee. $3 million in revenue was lost over a few hours. Don't think that's enough? How about Target? They did an update to the register system. Went down for 2 days in a row. $50 million in lost revenue. That's a retail store. Can't sell stuff without software. It's everywhere. So, I mean, just take Sweden as an example. I mean, this here. It's practically useless to me unless I deposit it into my bank account. I can't even buy a falafel with it. I need to use my credit card or my phone. Like, buying street food is dependent on software. That's ridiculous, but it's true. So, I mean, we've built ourselves into this thing where we can fairly say that the quality of our lives depends on the quality of software out there. And this is why what we do is important. This is why the quality of what we do is important. And this is why I'm afraid of all of you guys. So please don't kill me. I mean, I'm saying this because I feel our industry is in a crisis. And it's been like this for a long time. Already in the 1960s, the term software crisis was coined. Software crisis is defined as difficulty of writing useful and efficient computer programs in the required time. So here's what Dijkstra said about it. So basically, when we had no machines, we didn't have any problems. We got more powerful, more complex machines, got more problems. And the machines are complex, they're harder to program, we have less people being able to do it. We run into trouble. So make no mistake, we're an industry in crisis. So, all right, I'm going to put people on the spot here. So when was the last time you wrote flawless software? Anybody who wrote some flawless software in the last 15 years, raise your hand. The last 10 years? No. 5, 3, no. Nobody. I mean, so you see, I mean, either you guys are really, really humble or I just proved my point. Like, that doesn't exist. And in the specifications for the HVAC, this is what von Neumann said. The instructions which govern this operation must be given to the device in absolute exhaustive detail. He knew what was up, right? He knew that the programming needs to be perfect in order for it to work. But with the complexity of the devices we have today, this doesn't fly. So I'm going to tell you a few stories about when this went horribly wrong. I talked about, how the quality of life is improved by software. This is actually 4 different times where software killed people. So, first one is this. This is the Therac 25. It's a radiology machine, state-of-the-art, invented in '82 by a Canadian company. So it was state-of-the-art, right? And it was state-of-the-art, and in June 1985, a woman called Katie Yarbrough, which was 61 years old, went in for her final radiology treatment for breast cancer. Katie, she knew how this works. She's done it before. It only takes a few seconds. It's fairly painless. So imagine the shock when she felt a burning sensation in her chest. Of course, she complained to the doctor, but nobody took her seriously. Unknown to anyone, Katie was hit with 10 times the prescribed amount of radiation. Eventually, she got burn wounds and died. The doctors, they tested the machine, and they even reported to the company who tested the machine, but on each test, all the fail-safes kicked in. There was no error in the machine that they could find. Over the next couple of years, many people got hurt, and 5 more people had to die before they discovered a very, very weird concurrency error in the code, which caused this problem. When they did an investigation, they basically said, it's the architecture that's wrong. So it wasn't like any single line of code. It was like the whole architecture. It was written in assembly. It didn't use practices. You couldn't unit test things in isolation. So it was built for failure. This one is the Patriot Missile. So a Patriot Missile, big missile battery made to protect from Scud missiles. So when a Scud missile comes, this is supposed to hone in on it, shoot it down so it misses its target. In 1991, during the Gulf War, one of these failed to launch. The Scud missile hit barracks, killing 28 US soldiers and wounding over 100 people. So what happened here? Well, the thing was that inside of this was a really, really weird piece of code calculating time from boot. And due to an arithmetic error, it calculated that wrongly, which was then used for distance calculations. So this thing was looking to verify the missile about 700 meters from its actual target, right? So when it went to verify the missile, it said, oh, there's no missile, so it didn't fire. And what's even more weird is when they opened the code up and looked at it, this error had been fixed in some places, making an even worse problem because it used to cancel each other out. So somebody knew about this, just didn't go all the way with fixing it. And in testing, I mean, this was a thing which only showed up, or the problem was worse, the longer the machine ran. So in this case, the machine had been running for 100 hours. But when you just boot it up and test it, it works fine. And this one, I mean, I think everybody knows about this one, right? So this is the Boeing 737 MAX 8. But the reason I bring this up is because it's a super interesting example of where software goes wrong, but it's not actually software, right? So 2 plane crashes in 2018, 2019 killed 189 people and 157 people respectively. We all know about this. But what we need to understand is why does this happen? So what happened here was Airbus announced. So for anybody that doesn't know, Airbus and Boeing are like the 2 biggest people in the commercial airline industry. And they fight with each other. They have like fierce competition. If one of the companies launches a product, the other stands significant financial risk if they don't follow up with a similar product. So Airbus released a new model of their flagship airplane with bigger engines, which would save 15% on fuel. And what was even cooler was that the plane did not differ from its predecessors. So the pilots needed very little training to fly the new Airbus. This put Boeing into crisis mode. 2 months later, Boeing comes up and says, we figured out how to put bigger engines on the Boeing 737. Cool. The problem with the Boeing 737 is it sits very low to the ground. So fitting the engines, the engineers had to actually put them up on the wing. So you can see in this picture here, the actual engine is up on the wing. And of course, Boeing wanted to make the claim that Airbus was making as well. You can fly this plane with like no little new training, right? So the pilots don't have to learn a new airplane type and everything. Problem was, by putting the engines like this, the plane started pulling upwards when it was in full thrust. Boeing's solution? A piece of software. Piece of software used sensors, so when they discovered the plane was pulling upward, it pulled the plane down. This is the MCAS. This is the piece of software that probably due to a sensor failure pulled down the plane and made them crash. So it's a very, very interesting case for software. This is my last example. So I brought this in because everybody here is going like, yeah, I'm not building airplanes, I'm not building like medical devices, whatever. So this is, this girl here, she's, just gonna check the name so I get it right. This is Jacqueline May. She was 22 years old, and her friend had big startup ambitions. So he wanted to build the new video sharing platform, like the cool thing. It happens in London. So he's working on this app that's going to be able to, share videos between your friends. Inside of the app, you can send links to external users. They can access it over the web and stuff like that. And, Jacqueline was his friend, so she had access to the app. It was, downloaded through test flight or whatever. And she was using it because you want to support your struggling startup friends, right? And doing videos. And when she was chatting online, she did a little Spice Girls thing, recorded herself singing "Wannabe," so like, "If you wanna be my lover," and posted it online in a chat room, right? So it goes out in this chat room, and and she logs off and goes about her stuff. What she doesn't know is that this gets viral over the internet, and somebody somewhere shares it on 4chan. That's trouble. And of course, the amateur site goes down because of all of the links, people coming in and everything. But somebody scraped it before it crashed. And what probably nobody knew except for the developer was that inside of the HTML metadata was the GPS coordinates of where the video was recorded. This was going to be used for a later feature in the future, which, startups stuff, putting stuff out quickly. But as this video gets shared and remixed and everything, somebody figures this out, and the word flash mob is mentioned. And as Jacqueline is coming out of the shower, she just hears this noise outside her window and goes out on the balcony, and there's about 100 people gathered in the streets of London, just, dancing to music, having fun, and going like, "Wanna be, wanna be." They want to get Jacqueline to sing the song. And it's all crazy, and the neighbors call the police, and the police shows up, right? And eventually what started as a flash mob and a street party turns into a riot. 28 people got hurt. And when the dust settles, the door to Jacqueline's apartment was forced, and she was found murdered inside. This is a fake story. That's not true. None of that actually happened. But it's a story which I borrowed from... This is a story which I borrowed from a video called Flash Mob Gone Wrong on Ignite Talks. All of these things that I mention here have happened, but not in conjunction with each other. So this is a potential case that actually could happen, just to illustrate the responsibility we as developers have. So you see these examples, they're spread out in time. It goes from like early 80s to modern time. Make no mistake. The software crisis is growing. This is a growing problem. We can't put out quality software. We're pushed by the industry to produce as much as we can, as quickly as we can, and preferably at as low cost as is humanly possible. It's not a sustainable way of working. So please don't kill me. I mean, that's my only plea. I do try to stay positive. I mean, this is the retrospective prime directive, and I truly believe in this. I know that this is true for everybody here. I know that everyone is trying to do the best job they can with what they have, with the time available to them, and the resources and the skills. But what if that's not enough? What if the job you could do was not good enough, or if the skills and abilities you have or the resources you have are not enough to do a good job? I mean, and even worse, what if you knew that it wasn't enough and you did it anyway? We as developers, I mean, we're a funny bunch. We're fun-loving, we're happy, we love a good puzzle, a good challenge. We're usually pretty disciplined, and we want to solve issues, and we want to help out. We want to help out our users, our employers, the product owners. We figure out solutions. That's what we do for life. And that sometimes puts us into trouble. That's actually sometimes our downfall, because we do weird compromises to make people happy around us, to be like, I solved the puzzle, see, I can do it, right? And we're only trying to do good, but sometimes that good becomes really, really bad. And I don't think it's our fault. I really don't think that most of it is our fault, because Friedrich Nietzsche said God is dead. And the point he was trying to make was a comment on the Age of Enlightenment. Basically, what Nietzsche was talking about here was that we removed God from the things we were doing and basically replaced him with science and capitalism. And that's the society we're living in today. Those are the drivers behind all the things we do. So, please don't kill me again. And I think being a good craftsman, writing tests, running short iterations, etc., it's great, but I also think we need to understand the consequences of our creations and take responsibilities for them. I believe we need to have strong ethics as coders, and luckily that does exist. This is the ACM IEEE Software Engineering Code of Ethics and Professional Practice. How many here know about this? Okay, so some. Now all of you know about it. It's great. And in light of this talk, I'm just going to run through it quickly. We look at the EDVAC. Approve software only if you have well-founded belief that it's safe, meets specifications, passes appropriate tests. Sure, but even more, if you look at the code of, if you look at the code of THERAC, you can ensure the quality of, you have to ensure the quality of your skill. That you're qualified enough to work on the project. The developers doing this probably weren't, if you look at the code. The missiles, well, again, same thing. Approve software only for blah, blah, blah. But take responsibility for detecting, correcting, and reporting errors in software and associate documents on which they work. So somebody found this bug and tried to fix it, but didn't do it all out. Boeing. Moderate the interest of software engineers, the employer, the client, the users, and the public good. Somebody could have said, the pilots should just learn to fly this plane as it is. We shouldn't fix this in software. But it was fixed in software. And another one for the Boeing. Ensure that specifications for software which they work on have been well documented and satisfy the users. It's not sure. Nobody knew if the pilots wanted it this way. This was a commercial decision. And my made-up example of Jacqueline. So, work to develop software and related documents that respect the privacy of those who will be affected of that software. And work to follow professional standards, in startups. Don't just toss a bunch of things together, even if it's just a hobby thing. Make sure it follows professional standards. With all this said, I don't know if any of the lives in my cases would have been saved if we had stronger ethics. I can only hope. And I don't know if any of you will go back and read the whole document in software ethics, so I'm just going to leave you with a couple of parting thoughts before I go off stage. Be responsible. So, I mean, take responsibility for detecting, correcting, reporting errors in the software. Not only your own software, other software you find. You use somebody's app, you find an error in it, make sure to report it. Have skill. Make sure you're qualified to work on the stuff you're working on. I know we all want to do the exciting new technologies that we haven't done before, but don't do that in production unless you've had the proper training, you have the experience, or if you're doing it in production, make sure you pair up with somebody that understands the technology. This is how mistakes are made. Honor quality. Approve software only if you have a well-founded belief that it's safe and meets specification and passes appropriate tests. And last thing, please don't kill me. Thank you very much. I'm Martin, and it's been a pleasure talking to you.